Here's an amphibolite gneiss from the Snake Range of Nevada that has a very planar surface directed toward the camera. The lower surface is very, very planar, not exactly parallel to it. There's very well developed mineral lineation defined by amphiboles and plagioclase. Now that the two minerals, this white streaky mineral plagioclase and the dark streaky mineral hornblende, have both streaked out in the direction of the lineation, that signifies that these rocks were quite hot above the temperature when plagioclase would deform plastically and amphibole would readily recrystallize. Seeing that there's a lineation and a foliation together give us some access to the motion plane, a subject introduced yesterday. The plane of conceptual reference in which we can make good determinations about motion. The lineation for a field or a sample determination we can take as being parallel to the stretching axis of strain, or X, and the foliation we can take as being a good representation of the shortening direction for strain perpendicular to the foliation. The shortening axis Z would be a line or pole that's perpendicular to the foliation. If we want to orient the motion plane for our field of view, we would go parallel to lineation, perpendicular to foliation, using an aid of a plexiglass board. The motion plane orientation would be like this: parallel to lineation, perpendicular to foliation. And for viewing, I would want to take a view of the plane, a direction in which I could interpret kinematic sense. Looking at a different sample, let's say this one, okay, if this metaquartzite were oriented in space like this, with its streaky biotite lineation and quartz ribbon fabric or hot striae from quartz, the motion plane orientation would be like this: perpendicular to foliation and parallel to lineation. Therefore, the interesting viewing direction for this example of nearly strike-slip striations, providing an indication of the stretching direction of strain, the viewing direction for the motion plane would almost be straight down at a horizontal plane. Now, these two samples have a descriptive term that we could apply to them. These would both very well and in shorthand be described as LS tectonites. So L for lineation, S for foliation is the symbology. It's because the symbols were determined by French geologists who worked in the Brittany region of France. The S stands for schistosity. So LS tectonite, where the term tectonite refers to a beautifully deformed foliated lineated rock from the middle crust of Earth. Okay, of course, in the background we'll be thinking, well, these aren't the sort of rocks that we see deforming at the Earth's surface. They must have gotten to the surface of the Earth somehow, so faulting is likely responsible. Either contractional faulting or extensional faulting had a role in getting these rocks to the surface. And if we're looking at these sorts of rocks that have dramatic mineral fabrics like that, frankly, to put our minds into the realm of interpretation of the metamorphic rocks, we're going to filter out things that look like cracks and fractures. That's not the focus of interest if the work is about the type of deformation that does not involve brittle failure on fracture surfaces, no cracking, no breaking, but rather rocks forming these fabrics while they maintain cohesion through microstructural to macroscopic hygroscopic processes that allow the rocks to flow without breaking. Okay, now we spoke about LS tectonites. Here's another one that I'm going to return to in a little bit. But this rock is a gneiss, evidently, as introduced yesterday, from the presence of all the medium-sized feldspars in here, evenly distributed amongst biotite and quartz. This started out as a granite, and it's now a granitoid gneiss. But there are very regular fabrics and interesting geometries in this rock. First of all, a foliation, but the foliation isn't really a breaking plane the way it was for the metaquartzite. Rather, there's an organization and arrangement of mineral crystals inside that helps show a side-to-side layering of dominantly feldspar, dominantly biotite, zones very thin with quartz, and so on, repeatedly up and down. Now, this rock does have a lineation, but it's so narrow, it's difficult to see on both sides. The lineation is a streaky pattern formed by biotite and plagioclase. So this also, even though it looks far different from these platy samples, this is also an LS tectonite. And we'd also term this a myelinitic gneiss, something I'll get to in a minute. Okay, well, LS tectonites are one variety. We could also have amazing samples, and I'll show you 3 today that are L tectonites. So looking at the samples, I'd like you to try to work out what that means. Okay, so here's one example. Okay, there's a very similar lineation than we saw before, but here it's dominated by biotite and gray minerals, which are mostly quartz. There's and other subsidiary minerals in here. But look at this thing. It looks like wood grain. And if we looked end on, can you do that with the camera? It almost looks like there's rounded shapes or sort of a pencil structure to this. So and you can back up again. The fabric of this one has a stronger linear component than flattening component. Stronger L than S. So this would be an L tectonite. Here's another example in a quartz-rich rock that has loads of muscovite and biotite. This is also from the Snake Range in Nevada and has this grainy texture resembling wood grain. And if we look end on at that, the black shapes here, biotite, which look like lenses on the quasi-layered surface, if we look end on, they look much more like spots. If I rotate the sample over, well, I wrote on that side. But if we look end on that way, it looks like there's rods or sinews, like in a muscle, coming out toward us. It's especially strong on that surface. This is another example of L tectonite. And the final one is this one, which is a beautiful rock I just took out of our garden. I have these things all around the yard so I can enjoy their features. But again, it looks like very, very strong rods or lines that are assembled in a bundle. And if we look edge on at those, end on at those, it's very difficult to see any regular layering. Oh, one more L tectonite. And this one is really just an astonishing beauty. It's very dense and it's studded with equant garnets. So these garnets are dodecahedral, of course. They act like a round element within this linear feature. So it wasn't possible to stretch those garnets out under the temperature and pressure conditions that this meta-amphibolite felt. Okay, let's pause there.